Hi, welcome to Chapter 2, Section 3, Solving Systems of Equations Using Technology. Now, you did the hard part. You solved using substitution and elimination, and then we're going to make it a little bit easier, and we're going to solve it with a calculator, which is entirely possible. So, in order to do that, we need to know how to set up what we're going to put in the calculator, because you can't just put the system in the calculator the way you see it. We have to do something else. So, we're going to deal with matrices. And a matrix is a rectangular arrangement of numbers. Okay? Well, a matrix has dimensions. So the dimensions of a matrix with m rows and n columns are m by n. And that's how you say that. So the x is a by. And when we're talking about rows, we're talking about horizontal. So these are your rows, and these are your columns. And remember that columns, like if you've ever seen an old building, they have columns on them that hold up the front, and those are going up and down. So remember that columns go up and down because they hold up a building. They hold up a structure. And so our up and down, those are our columns. Then the rows are the other ones. So now that we know what everything means, we need to be able to write an augmented matrix. And that's the same thing as what we did in the two variable system notes, right? I told you to write a matrix. I showed you how to do it with a system of equations. And that's really just, that's all it is. So, but you're going to see the word augmented matrix all the time. So I want you to associate that with all of those constants and then the equals, whatever they equal after the line. Now, in order for this to happen, you have to have your system in standard form with a constant term on the right. Okay, this is very important. That is very, very important. If it's not, you're going to get something wrong, and then when you put it into your calculator, it's going to give you the wrong answer. And you're going to be like, why? Why did it give me the wrong answer? Well, because you didn't have it in standard form, so your things were in the wrong places. So let's make sure we can do that. Example 1. First, let's practice reading instructions. Write an augmented matrix for the system, then state the dimensions. So first we write our matrix. Now we have to make sure that this is in standard form. That means all of our variables on the left and our constants on the right. And we have 5x plus 6y equals 13, that's fine. 8x minus 2y equals 2, that's fine also. Okay, and they have to be in a specific order. They have to be in x, then y, and then if we have 3 variables, the z. So this works. So we're going to go ahead and put this in a matrix. And remember, when we put it in a matrix, we're just dealing with numbers. If you put a variable into a matrix and you try to stick that in your calculator, it's going to give you an error because it doesn't have x or y defined. Okay, and so just don't worry about all that and don't put variables in here, just numbers. So we're going to put our 5 and our 8. So we have 5 and 8. Then our 6 and our negative 2, right? You have to go with the sign that you see in the equation. Then you have a line, and then our 13 and our 2, right? Remember that line is like an equal sign. Well, that's our matrix, but it says then to state the dimensions. So we're going to do rows by columns. Rows by columns. Remember, rows are going horizontally. So we have 2 rows. So 2 by our columns, well, we have 1, 2, 3. So 2 by 3 matrix. That's what we have. And that's it. Let's go on to example 2. Well, first we have to look at this and say, is this in standard form? Well, we have a 2x, 4yz, 3x minus 2y plus 2z, 6x minus 3y plus z. So that's fine. That's fine. So we'll go from there. And we write our coefficients. Those are the numbers out front. So we have a negative 2, a 3, and a 6 going down. For our y's, we have a 4, a negative 2, and a negative 3 going down. For our z's, we have a negative 1, a 2, and a 1 going down. We draw a line, and we have our equals. Okay, so this is not the same size matrix as before. It's going to actually have a different dimension, because this time we have 3 rows, because there's 1, 2, 3. And then we have 1, 2, 3, 4 columns, so it's a 3 by 4 matrix. And that's it. Now let's go into what it looks like if it's not exactly the way we want it to be. So, for example, 3. We have 3y plus 4z equals 12, 6x plus 8y minus 9z equals 32, negative x plus 5y minus 2z equals 1. So that's in standard form. But if you look at it, we are missing a variable in the top. And that is okay. That is perfectly fine. What you might want to do, though, is rewrite it, because if there's not an x, how many x's do we have? Because there's a numerical value for nothing, right? It's that 0. So I'm going to rewrite this, but instead of writing my 3y first, I'm going to put a 0x. So we're going to have 0x plus 3y plus 4z equals negative 12. And notice I didn't change anything else. I just put a 0x as a placeholder, because when I write my matrix, I need a 0 there. Okay, so if you need to do that to make sure you don't make a mistake. So here we have 6x plus 8y minus 9z equals 32, negative x plus 5y minus 2z equals 1. Now I didn't change anything else because the other two equations have everything. So now I can write my matrix, right? And we're going to use the coefficients. And the coefficients for that first x is 0. We have a 6 and a negative 1. We have a 3 and 8 and a 5 in front of our y's. We have a 4, a negative 9, and a negative 2 in front of our z, a line. And then after the equal signs, we have negative 12, 32, and 1. Okay? But we have to make sure that we are answering the questions. It still says to state the dimensions. So even though it's the same as the last one, we have 3 rows, because we have 1, 2, 3 rows by 1, 2, 3, 4 columns. So we have a 3 by 4 matrix. Now, my last example for you is going to be one where we don't have everything in standard form, right? We have 9x minus y equals negative 4. That's fine. That's okay. So, but, right, we have a situation like we did in that the example 3, in that first equation, where we don't have a z. So when I write my new matrix, I want to make sure I leave space, or I write 0z. So 9x minus y plus 0z equals negative 4, because I don't have any z's there. Now if we look at our second equation, we have 4y plus 8z equals 2x plus 3. That means that my 2x is on the wrong side of the equation, so I need to move it over somehow. And when I do that, I'll come down here. 4y plus 8z equals 2x plus 3. And I need to move it to the other side, so I need to subtract it from both sides. Okay? I have to eliminate it from that side. So we have to have negative 2x plus 4y plus 8z equals 3. Now it's in standard form, and now we can continue. So I'm going to put that in here. The negative 2x plus 4y plus 8z equals 3. Okay, and then our last one is 5x plus 2y equals 8z. Well, that 8z is still on the wrong side, just like it was for the second equation. So we need to move that over. So we have 5x plus 2y equals 8z. We need it on the other side, so it's positive, which means we need to subtract. Okay, now whenever we cancel those, that becomes 8 minus 8. Well, 8 minus 8 is 0, so we're going to have that equal to 0. So we have 5x plus 2y minus 8z equals 0. That's our final equation. So let's put that in here. 5x plus 2y minus 8z equals 0. Alright, so now we can write our matrix, finally. Right? So our matrix is going to be all of our coefficients. So for my x's, we have 9, -2, and 5. For our y's, we have -1. Remember, if there's nothing written, it's an implied 1. If it's not there, it's an implied 0. But if there's nothing written out front, it's a 1. Our 4 and our 2. For our z's, we have 0, 8, and -8. A line, and we have -4, 3, 0. And once again, we have our dimensions, our rows, 1, 2, 3, by column. So 1, 2, 3, 4. So we have a 3 by 4 again. All right, now, just so you have it in your notes, we're going to address this in class because you don't have your calculator with you at home. This is how you solve a linear system using technology, and you're going to really like it. So make sure you have any questions prepared for class if you have any. Thank you.